the last couple of weeks on your lecture series actually. So this for the next couple of weeks, like 2 to 3 weeks, we will be going to cover up the IPv6 concepts, where we are going to discuss about the depth analysis, depth understanding on the IPv6 environment that will give you support to or lead to deal with the configuration of IPv6 in future as well. So this is one of the trending technology, especially related to the networking. So where you will be going to deal with these concepts very much heavily in this aspect as well. Right. So by having said that, what we are going to do on here is the we will be going to discuss and define or discuss about the IPv6 concept. So guys, if you can remember what we have gone through on the early days of this particular lecture sessions, so can anyone tell me what is the IPv6 address space? Like for the IPv4, you know that what is the IP address space. So can you just tell me what is the IPv4 and the IPv6 address space? Guys,
8
hello?
bits.
I didn't get you.
Address space is 1 to 8 bits in IPv6.
Yeah, exactly. So that is 128 bits on the IP address space. What is the address space on the IPv4?
32 bit.
Exactly correct. So that is going to be the 32 bit. So we have already learned about the 32 IPv4 address space. What we are going to learn today is the important.
128.
Yeah, exactly. So basically, we can create the IP address space of 2 to the power 128. That is, if you look at that 2 to the power 32 into the 4, number of 4 times. So just imagine number of IP address, that is obviously. So they can able to contribute, simply they can able to contribute for a next couple of centuries actually. Like even if you look at the this this 21st century, so whatever the IP address which are in the IPv6 address space, and then whenever you going forward with the 22nd century also, so we are still almost in the 21st century. So once you complete the 22nd century, once you starting on the 22nd century also, so so of course you will the number of IP addresses that you are having is not pretty much enough for the for that those things. Basically, for the definitely for the next with any other IP version addresses, because V6 definitely will be able to cater to the requirement. Even for the next century or so, example, now we are on the total world populations like 2020, we'll see it's 7.8 billion. Of course, that is just even for the next, like let's say for example, for the double the size, even we have double the populations, that is 14 billion, still that is possible to cater with the IPv6. So definitely IPv6, they will be able to uh, move ahead without the IPv internet protocol versions, because versions centuries as well, like 22nd. I don't think that in the next century the population will be double. So that is of course there is uncertainty on that with this epidemic situations, like you can see now, epidemic situations. So the deaths are increasing than the birth. So that is the major concerns that we have, right? So by having said that, so we are going to start the discussion on the IPv6. So you can see now we don't want to worry about the IPv6 address. So if you want to learn the IPv6 address scheme, it's something like this. So since it's a 128 bit, so of course it is not possible to deal with the IP address cannot be described. So whenever you are dealing with the IPv4 IP addresses, so IPv4, the IP address can be described with the two-base mathematics or by using the decimal. IP can be described with either using binary value binary value or decimal value. That is possible. But since we are using IPv6, we are using with the huge size of IP address space. Obviously, definitely we can represent the IPv6 address space with the by using the binary, but it is not possible to define it with the decimal. So by using binary, we can definitely define, but it is not possible to define the IP address using decimal value. But yet again, what you can do is you can simply what you can do is you can what we are going to use here is not the decimal, but instead that we are using the hexadecimal value. Do you know what is the hexadecimal value? So in that case, IPv6 address can be defined by using binary and as well as the hexadecimal value. Do you know what is the hexadecimal value? Hexadecimal value.
Asepade.
Exactly. So 16 base mathematics. Dasepad again 16 base mathematics. So here what we are going to look at here is the 16 base mathematics, which is going to be a several important concepts that we will be using. So whenever you are going to use the 16 base mathematics, it should include 15 numbers. Like when you say 10 base mathematics, 10 base include 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So altogether by combining these number values, they can generate any type of a number. So it's just a so 10. So when it comes to the 16 base mathematics, that's a part there. So it should contain the 50 numbers. Sorry, 16 numbers at since 16 numbers will be going like 0, 1, 2, 3, 4, 5, 6, 9. From the 10 onwards, they are going to not giving you any mathematical numbers. What they are referring here is number 10 will be represented by using the letter A. Number 11 will be represented by using the letter B. 12 represented by letter C. D represented the number 13. E representing the number 14, F representing the number 15. You can see now it contains 16 numbers in this particular 16 base mathematics. 16 number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 numbers in this 16 base mathematics. So that is what exactly you need to refer in this particular locations. So by using these number series, we can define the 128-bit number values, 128-bit IPv4 v6 address in a hexadecimal manner. So I'll show you hexadecimal when you're designing the hexadecimal. So in IPv6 we use the dotted notation. So in order to separate the 8-bit values, so we use the dotted notations. In here we can't use the dotted notation. Instead of that, in order to separate the values, we use the colon. In order to separate these values, we use the colon. So one colon will include 16-bit values. 16-bit, 16-bit, 16-bit. So basically, yeah, someone has sent me the answers as well. So basically, you can see, so each this particular block which is separated with the colon will have a 16 bit of blocks. 16 bit, 16 bit, 16 bit. In here also you can have a 16 bit and then again 16 bit. Can you tell me how many number of blocks should be there with the 16 bit? 1, 2, 3, 4, 5. Guys, 16 bit, 16 bit, 16 bit. 1, 2, 3, 4, 5, 6, 7, 8. So exactly 8. So 16 into 8 will exactly equal to 128. So you can see the address space how they are going to do is 16-bit uh, values with the colon separated fields. It is into 8. So 1, 2, 3, 4, 5, 6, 7, 8. 8 16 bits. Clear, guys? So if you write it down the numbers like I already told you, one bit which is exactly equal to digit 1 or 0 when you're dealing with the binary. So you can here in that means whenever you want to have the 16 bit, you need to write it down 16 1 or zeros, combination of 1 or zeros, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 colon 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 6 7 8 9 14 15 16 colon 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So now we have 1 2 3 4 5. Another 3 we need to write it down. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So now altogether we have one field, second field, third field, fourth field, fifth field, sixth field, seventh field, and the next one is the eighth field that is concluding the 128 bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if you count these all one and zeros, this is exactly having 128 one and zeros. Are you clear, guys? So conclude conclude the IP address, IPv6 address in a binary format. Is it clear, guys?
Yes, sir.
Yes, sir.
Sir.
Right. So right. So if you take this one, if you look at this one, so I told you that it is not possible to write it down this thing in the decimal numbers. So what they have done was they have write it down in the hexadecimal. So whenever they are going to write it down the hexadecimal, that is the 16 base mathematics. In order to take the 16 base, if you can see here, so these 4 bits will exactly equal to one hexadecimal character. These 4 bits, sorry, these 4 bits will exactly equal to, so if we take this one, these 4 bits, so these 4 bits will exactly equal to the another hexadecimal character. Then again, these 4 bits, so likewise, so the 16 bits in the one per sector, first field can be fallen under the 4 hexadecimal numbers, like see here. So I'll just take the calculation. First 1010, that is the first hexa character. Then again we are having 1010, that is another hexa character. Then we are having 1100, that is another hexa character. Lastly we are having 141. So this is one hexa character. So the way that you are going to take this into the hexa character is just a simple thing. Convert into the by multiplying the 2 to the power value. So first one, this one will be carried out like 2 to the power 0. So if I write it down in here, 1 0 1 0 will be like, write it down here, multiplied by 2 to the power 0 value. 2 to the power 0, that is exactly 0. See, this is multiplied by 2 to the power 1 value. This is exactly 2. This multiplied by 2 to the power 3 value. This is exactly 0 again. This is multiplied by 2 to the power 4 value. Exactly, what is the number? Sorry, 1, 2, 3. Sorry, this is multiplied by 2. This is multiplied by 3. Sorry guys, my mistake. So exactly this is 8. So 10 in the sense this first 4 bits will represent in the letter A in here. Letter A, 10. Then again, next one is also 111010. That is also representing letter A. Then next one is 1100. If you convert it to the hexadecimal, this is going to be 2 to the power 0 is a 0. 2 to the power 1 again into the 0 is 0. 2 to the power 2 is 4. 2 to the power 3 is 8. 8, 4 is 12. 12 in the sense in here, 10, 11, 12 is a C. So next one is all ones in the sense that is containing 15. 15 in the sense it's F colon. So likewise, you can rebuild this, you can build this particular 16-bit portions into the 4 letter of hexadecimal characters and build the 128. So you can see, of course, we are not going to build that in these particular calculations, but I'll just put it like this manner. So it can be write it down in like AACF and then again F F F F C0. Just to give you idea that I'm not exactly converting these things. F0 B0, then again sorry F0 B0, then again we'll be say EEFE 0 1 2 3 1 2 3 4 5 6 3 4 5 6 7 8 9 whatever the 9 1 2 3 4 5 6 7, and the last one will be containing this. So this is what we says as a IPv6 address. Six address. Do you have any issues, concerns so far what we have done? So likewise, you can write it down the IPv6 address in a different, by most probably whenever you want to deal with the IPv6, as a very common method in the IPv4 that we have used the decimal notations. In here, we are using this hexadecimal notations. Keep in mind that each single character in this will representing 4 bits. So A letter is representing 4 bits. I have shown you how it is representing. A letter representing 4 bits, C letter representing again 4 bits, F letter representing again 4 bits. So each letter in this particular 128-bit IP address space in a hexadecimal manner will representing 4 bits for this one. So that's why I want to show you. Definitely it contains 128 bits. This is how it concluded the 128 bit into the hexadecimal numbers. Is it clear, guys? Do you have any issues, any concerns so far what we have done? Guys, I need your feedback.
Little bit weird.
Okay, so that means do you need more clarification or more again? Do you want to go through this same thing again?
Maybe again, sir.
Yeah, sure, sure. What about the others? Guys, what about the others? Some are saying clear, but anyway, I'll just explain it again. So just to get the idea again. Okay. So as I told you, the IPv6 address space. The IPv6 address space. Just give me a second, guys. Right, guys. So I'll increase the font size. That is, of course, possible. Can you see it now, guys? Like, is it possible to see it now?
Yes, sir.
So, person who has to be uh, with the soon are you able to increase the size font size? So I guess you can see it right now.
Okay.
So basically, yeah. So basically, I told you that IPv6 address space will contain 128-bit values, 128-bit address space. It is what we are actually going to look at in this particular context. That is exactly what we are going to do. IPv6 bit address space what we exactly going to look at here is the way that they are going to write it down, 128-bit address space in this particular environment is it's something like this. It is containing basically in IPv4 we use two ways, like in order to declare, in order to define the IPv4 address. So we use a binary, or the binary value based IP address scheming, and then again the decimal address base decimal. So you can define the IP address in binary manner, that is 32-bit address space, and then you can define the IPv4 address in the not even the binary manner, but also the IPv6 address space. Since it's a large address space, it is not possible or it is not practical to use it with the decimal value. So what they have defined, the IPv6, what we can use is we can use the binary base. Of course, that is possible, and then we need to use binary value, and then what we are going to use, we need to use the hexadecimal, that is we call it as a dase padege dase, that is a 16 base mathematics. Hexadecimal will goes like a 16 base mathematics. 16 base mathematics. So that is exactly what we are going to deal it within here, like a 16 base mathematics. So the way that we are going to do define this IPv6 addresses by using the binary values, because once you say binary values, only numbers that are available for the binaries is either the 0 or 1. And again, when you say the decimal, if you say the decimal, so for the binary mathematics, binary or second base mathematics, the two numbers will be available, 1 and 0s. Decimal number, decimal base mathematics, 10 base mathematics, that is available 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically, these are the things that is available. Hexadecimal mathematics, what they are available is 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and finally F. E and finally F. So 9, 10 stand for A, 11 stand for B, 12 stand for C, 13 stand for D, 14 stand for E, 15 stand for F. This is the numbering mechanism of the hexadecimal like binaries. So by using these numbers, we can generate any type of hexadecimal number that is possible. So of course, if you write it down the IPv6 addresses in a simple way, so the layout of the IPv6 addresses, if you look at the IPv4 address layout, what they have done was they have used 8-bit value with the dotted decimal notation, 8-bit separate the fields. So with the dotted decimal notation, so 8-bit into 8-bit, 16-bit, 24-bit, and the 32-bit, that will conclude the IPv4 addresses. This is the structure. So 8-bit in the sense, if you write it down using the binary mathematics, of course, the binary mathematics will be concluding simply 1 bit exactly equal to 1, either the 1 or 0. So when you say 1 bit, so in binary maths, so either it can be a 0 or 1. So when you say 32-bit, this is has to be representing 8-bit 1 or zeros, 8-bit 1 or zeros, 8-bit 1 or zeros, 8-bit 1 or zeros. That is exactly they are going to use it. When it comes to the IPv6, When it comes to the IPv6, what they are going to use it, they are going to use 16-bit portions with the colon separators. 16-bit, 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 16-bit. So 1, 2, 3, 4, 5, 6, 7, another 16-bit, and finally you have 16-bit. So 8 16-bit colon separators. You can understand that this is the IPv6 address structure. Is it clear, guys? Just to give you some spaces,
Yes,
that
sir.
is, you can understand it.
Sir.
So is it clear for everyone? So,
Yes, sir.
okay. So do you have any issues, concerns with this one? So everyone that I'm asking, do you have any issues or concerns with this particular? Guys, the others I need a confirmation. So basically, this is exactly what we are going to do it in here. So what we going to deal with this particular environment is like, so whenever you are dealing, if you have defined this IP address with the just 1 and 0, so we have to, we can define like 1010, 16 bit of combination with the 1010s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Again 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then again, we can deal with another like so let's say 1, 2, 3, 4, 5, 6, 7. Another the seventh 16-bit that you have in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you will be able to see that. You will be able to see that there were, like say for example, 16-bit of 16-bit portions into 8 fields like 1, 2, 3, 4, 5, 6, 7, 8. So 16 bits into 8 in the sense it is exactly equal to the 128. 128. Is it clear, guys? So this particular address can be converted like say this is for the first one. So whenever you are going to define this in the decimal notation, so this particular one will be like this 4 bits will exactly equal to the 116-bit character. This is why it says 116-bit character. Then again, these 4 bits will exactly equal to the 16-bit character. This 4 bits will exactly equal to the 16-bit character. These 4 bits exactly equal to 16-bit character. Always keep in mind that this 128-bit address space will be going to consider, will be going to define with one sections will concluding four four letters, four characters, which is having the hexadecimal manner. So if you write it down in here, so I'm not going to convert it again. I'll just convert it for the UR, that is for the learning purposes. 1010, that is the first four letters in here. Then again we are having 1111. Then again we are having all four zeros, and then again we are having 111. This is the first space that we are going to convert. So if you look at the 1010, this is having 0 multiple. If you want to convert it to the hexadecimal, 0 multiplied by 2 to the power value of 0, that is exactly equal to 0. Then again, 1 multiplied by 2 to the power value of that is 1, that is exactly equal to 2. Then again, 0 multiplied by 2 to the value of 2, that is exactly equal to 0. 1 multiplied by 2 to the value of 3, that is exact, so equal to 8. So this is say 8 plus 2 in the sense 10, 10 in the sense that is representing the letter A. In here, there 1010 will represent by letter A. If you look at the old ones, that is 1, 1, 1, 1 multiplied by 2 to the power 0, 2 to the power 0, that is exactly 1 multiplied by 2 to the power 1, that is exactly 2 multiplied by the 2 to the power 2, that is exactly 4 multiplied by the 2 to the power 3, that is exactly 8. So if you look at sum up all together, 8, 4, 12, 14, 15. 15 exactly equal to the F. So this one force will be representing F. So all 0 in the sense of course zeros, again all ones in the sense F. So likewise, you can convert this particular 16-bit address space into the hexadecimal values. So I'm not going to convert each and every one. So just for the time being, that I'm saying is AF0, F0, 0, whatever the 2, 3, and then 3, 4, 5, 6, 5, 2, 5, 6, 7, 8, 9, A, B, 6, 4, A, F, 0, 0. So just I'm not converting everything. 1, 2, 3, 4, 5, 6, 7, 8. So now you can see, so this is the 128-bit address space, which is containing one letter will exactly representing 4 bits, because this is a hexadecimal number. You can see how we are saying that this one letter is exactly representing 4 bits in a hexadecimal manner, because we have by using the 4 bits in the binary value, we converted to the hexadecimal address space. So this is, we call it as a IPv6 address space. In this manner, you can see it's a very long IPv6 long address in the format itself. So you can see there should be definitely 16 bits, 8 fields should be there with the colon separated values. So this is what exactly we are using. Are you clear, guys?
Yes, sir.
Yes, sir.
So what
Yes,
about, so everyone is clear with this IPv6 address space? Okay. So do you have any issues, concerns so far with this? So hope you are crystal clear with these concepts. So I don't think that you do have any issues with this this particular IPv6 addressing scheme. So this is what exactly we are going to use when you're dealing with the IPv6 addressing scheme. So by having this in mind, so we will be going to look at how you are going to write it down the IPv6 addresses, because since this is a very long IP address that we are going to use it, so we will be not able to deal with the long type of format. So it should contain sort of a short type of a formats. What they are going to do is they have sort of introduced several shortened format, like rewriting formats for the IPv6 address space. They have introduced two rules that we are going to learn it in here. Uh, that is going to be a sort of just a simple address space that we are going to use it, and we'll look at that one. So the first rule in here, we'll look at this one. The first rule in here is something like this. So let's say, for example, if you write it down like the IP address in this manner, one, two, one, two, three, four, 1, 2, 3, 4, 5, 6, 7. So let's look at this particular IPv4 address. So the first rule in here, first rule that they are defining, you can eliminate the leading zeros of the IPv6 address and write it in an abbreviated format. So what the first rule does says is, you can eliminate or you can just ignore the leading zeros of the each and every field. Like see here, you can see these three are the leading zeros, but these are not the leading zeros, because whenever they are starting the particular field, so they have been used the double E, and then they have used the back zeros. These are not the leading zeros, these are back zeros. But here also these two are the back zeros. These are the leading zeros. You can see these three are the leading zeros. These two are the leading zeros. These two again are the back zeros. So what they are saying is, when you want to have it in an abbreviated form of the IPv6 address, you can eliminate the leading zeros and rewrite it. So whenever you sum up this particular, whenever you tally with this particular first rule of thumb, what we can write it down in this particular IP address is 201 F colon EE002300 EEFF colon 54 colon 1 colon E00. This is what exactly they are going to say in the first rule, that what you can do is you can eliminate the leading zeros. Are you clear, guys?
Means if there are no zeros, we have to put if there are one character, we have to put 3 zeros in front of that character.
No. once you write it down your IPv6 address, once you write it down the IPv6 address, if that IPv6 address contain leading zeros, if that IPv6 address contains leading zeros,
Yes.
you can shorten the IPv6 address by removing the leading zeros. Here what we have done. But you can't remove the back zeros. Huh? So here you can see that 2401 F EE00 colon 2300, because we have put the back zeros as it is, EEFF, and we can remove the leading zeros in here, 00. Instead of that, we just put it, write it down the 54, and we eliminate all the leading zeros in here, put it the 1, and we put it AB00. So you can see now, this is exactly how we are going to normalize, how we are going to write it down in abbreviated form. Are you clear, guys?
Yes, sir.
What about the others?
Yes, sir.
Right. So the next one is going to be something like this. I'll again we'll go through another one, like say for example 2402 AF00 00B3, and then 001 2, like 000A, like then again 0000, and then again 1023, 1 2 3 4 5 6 7, the last one which is containing FFEE. So whenever you ask to shorten down this particular IPv6 address in abbreviated form, obviously you can write it down like 2402. We can't eliminate the back zeros, that is has to be there, but we can eliminate the leading zeros in here. So we just remove the double zeros in the front and we put it B3 only. We just remove the triple zeros on the front, we just put the 2 only. We just eliminate the triple zeros on the front, we put A only. In here, we just eliminate the front zeros and we put the 0 only. And we can't do anything in here and we can't do anything in here as well. So this is how you shorten your IPv6 address. Hope that is clear to you.
Yes, sir.
Do you have any?
අතන 0 එක නැතුවට ලියන්න පුළුවන් නේද?
පොළපොළ ඒක ඊළඟ රූල් එක මම කියලා දෙන්න. So this rule is clear to you?
Yes, sir.
Okay, what about the others? Others, what about are you comfortable with this one or not? So please give me your feedback. Huh? Guys, I need your feedback.
Clear, sir.
Everyone,
Yes, sir.
right? Okay. Okay, great. Right. So then we'll move to the next rule. That what they are going to do is, so the second rule here is, so whenever you are going to write it down the IPv6 addresses, you can combine the both rule and shorten your IPv6 addresses. You can eliminate consecutive zeros and write it down and zeros of the IPv6 address and write in a abbreviated form. So what you can do is in the second rule, what they are going to do is you can eliminate the consecutive zeros of the IPv6 address and write it in a abbreviated format. That is what exactly you can do it. That is what you can do, right? So this is what we says is 2401 colon 000, like let's say for example 0db8 colon 000 colon 000 colon 000 432 whatever the one 5670 bf colon 1 2 3 4 5 6 7, and then we can write it down in the EE00. So whenever we are going to use it in the second rule and the combination of the both first rule, we can write it down in this manner 2401, and we can eliminate these leading zeros. That is the first rule that we have learned, db8, and we can eliminate if you do have something like this, all the consecutive zeros. What you can do is you can put it into the colon, just eliminate everything and put it just a colon, and then you can write it down 4321 colon bf colon ee00. So this is exactly you are going to do it in here. This is exactly you are going to do it in here. So you can see, imagine now, this is how we are going to deal with this in this abbreviated form. 2401 0, we have leading zeros have been eliminated, db8, and if you do have the consecutive zeros that also have been eliminated, just put it only the colon, and then rest of the things can be also written. So whenever you require to rewritten this IPv6 address in the long format, obviously you can do it, because once you look at, okay, we have 2041 according to the rule. Here we have missed one letter. That means that definitely should be the 0, because they have removed the leading zeros, db8, and within this colon you can just calculate like 1 2 3 4 5. So you can see there are already 5 16-bit values are there, but it within this colon it should then again remain another 3 fields for the 16 bit. So that means we can write it down 0 0 0 0 0 0 0 0 0 4321 00 bf colon EE00. So you can right now look at this. This is contain 1 2 3 4 5 6 7 8 8 field of 16 bit, which is having the whole IPv6 address. Is it clear, guys? So I'll do another example here. We'll do several like exercises in here. Are you clear, guys? Let's see. So guys, are you clear with this one? With this second thing?
yes sir. සර් එක මේ එතකොට එක දෙකට බින්දු තිබුණොත් විතරද එහෙම කෝලන් දෙකක් දාන්න පුළුවන්?
ඔව් එක දිගට consecutive zeros තිබ්බොත් විතරයි.
විතරයිනේ. දැන් මැදින් අර පේරි තුනක් තියෙනවානේ. ඒ මැද නිකමට හරි වෙන ඩිජිට් එකක් තිබුණොත් එහෙම එන්නේ නැහැ නේද? එතකොට නේ.
මම පෙන්නනවා. ඒ කියන්නේ මෙහෙම that. So this is another example that we are going to do 0db8. So look at this 0 0 0 0 0 0, and then again we are having, let's say 242, and then again 00 bf, and then again 1 2 3 4 5 6 7. Like next thing is going to be like, see here 3120 0 0 0 is the last one. So now I guess මේක නේද ඇහුවේ, මේ වගේ කන්න ඇහුවේ නේ.
ඔව් සර්.
Right. මෙතන එතකොට මැද්දේ දැන් මෙතන consecutive. So you can see here there are consecutive zeros as well as another consecutive zeros in the end. So it's a breaking up. So we have 2 consecutive 0 fields, and there is another, once we have gone to the last, there is an that is also including the zeros. So when we write it down this one, so if you write it down in this manner, like 2401 colon db8 colon 2342 colon df colon 3210, then again we can just say the colon. If you write it down here, we just put it like here. You can say the issue is something like this. So when you want to rewrite the IPv6 address again in a long format, one, two, three, four, five. We have 5, and in the middle we have the colon, and in the end also we have the colon. But we should know, because we don't know that there is another 3 fields that we need to add in the 16 bits, but we don't know where to add it, because we can add these 3 fields. We can add 2 fields into the middle, 1 fields into the end, or we can add 1 fields into the middle and 2 fields into the end. So we have the issue that we cannot understand where to add, because this can be rewritten in this manner: 2041 0 db8 000, and then we can write it down 2342 colon 00bf 3210 colon 000. We can imagine that we can write it down in this manner, as well as then again we can imagine that we can write it down in this manner: 2401 0 db8 000 2342 00bf, and then 3210 and 000. So whenever you want to have exact IPv6 address in a long format, you can write it down this IPv6 address in a 2 different ways, because we can't understand how they have had that 0 consecutive zeros. Because of this confusion, obviously this is not the way that we are going to do it. So whenever they when asked to, this is wrong, wrong abbreviation, wrong shortened form. So whenever you want to deal with, what they are going to do here is they are going to exactly going to do like something like this. What we are going to do: 2401 db8, we take the most consecutive zeros and abbreviate it by using the reckon rule. So here we have the two consecutive zeros, so we consider this as and shorten it, and then bf and 3210. The last one can be apply only the first rule, say that the leading zeros will be removed and then will be put it in here. So you can see now it is going to be 0 here. So 2401 db8 colon bf 3210, and last one we are not going to put it in the second rule. We will just only apply the first rule and remove the leading zeros and put it in this panel. Are you clear, guys?
Yes, sir.
What about the others?
පොඩ්ඩක් සිංහලෙන් කියන්න පුළුවන්ද?
හරි, මම explain කරන්න. So what about the others who I will definitely explain in Sinhala language, but so I need the confirmation on the rest also.
සර් මුලට අය ඔය වගේ දෙකක් આવුත් එහෙම මුලටත් දෙකක් දානවනේ අර වල
තේරුන්නේ
මුලටත් මේ 0.4 දෙකම දෙකක් આવුත් එහෙම මුලටත් මේ කෝලන් දෙකක් දානවනේ
මුලට
එහෙම
කියන
පුළුවන්
කොහෙටද කියන්නේ?
මුලටම කියන්නේ සර් පටන් ගත්තීම
නෑ එහෙම දාන්න. එතනත් මේ රූල් එක තමයි ඇප්ලයි වෙන්නේ. මේ දෙවෙනි රූල් එකයි පළවෙනි රූල් එකයි විතරයි මම කිව්වේ. එකලං දැන් මේ වගේ කැඩිලා තියෙනවා නම් කන්සෙප් එක ළඟ තියෙන බිඳු තියෙන තැන් එතකොට දාන්නේ මේක තමයි යන රූල් එක. එතකොට එක ළඟ බිඳු තියෙන ඔක්කොම කෝලන් දාලා කරන්න බෑ වැඩේ. මොකද කන්ෆියුස් වෙනවා. එතකොට හැදෙන්නේ කොහොමද කියලා V6 address එක ආයේ full format එකේ. මම මේක සිංහල explain කරන්නම්. Guys I need the confirmation.
මටම තියෙන line එක පේන්නේ නැහැ.
මොකද?
අර රෝන් ෂෝට් ෆෝම් එකට පස්සේ සර් ලියලා දිනවනේ එකක් ඒක පේන්නේ නැහැ.
පේන්නේ නැද්ද ඒක? දැන් පේනවද?
දැන් පේනවා සර්.
Right. Guys, I need the confirmation from the people. Definitely I will be explaining this Sinhala language, but I need the confirmation from the people who speaking Tamil. So my dear Muslim and Tamil friends, I need your confirmation. If you require, then again I can explain it. Since the people who ask the explanation on Sinhala also, I will definitely do the explanation on Sinhala. Please give your confirmation, guys. I need it. Guys, I guess you are clear. So then I'll explain with this Sinhala language. So make a වෙන්නේ මෙහෙමයි. Basically පළවෙනි එකෙන් කියන්නේ ඔයගොල්ලෝ පළවෙනි එක clear නේ. දෙවෙනි එකේ වෙන්නේ leading zeros තියෙන consecutive zeros එක ළඟ තියෙන බිඳු තියෙන වගේ අයින් කරලා ඒකට කෙලින්ම බිඳු ටික නැතුවම ලියන්න පුළුවන්. එතකොට තමයි colon වැටෙන්නේ. හැබැයි මේක කරද්දී මේක තමයි දෙවෙනි rule එක. consecutive zeros එක ළඟ තියෙන බිඳු තියෙන ඒවා අයින් කරන්න. හැබැයි මේක ලියද්දි ප්‍රශ්නයක් තියෙනවා මෙන්න මෙහෙම consecutive zeros break වෙලා එක ළඟ බිඳු තියෙන ඒවා කැඩි යන. දැන් මෙතන දැන් මේක ඇවිල් උදාහරණයකට ගත්තොත් එහෙම 2401:000:000:000 එක consecutive set එකක් 2342:00:BF 3210 ඊට පස්සේ තවත් එක set එකක් එනවා 000 කියලා. මේක දෙවෙනි රූල් එකට දාලා ඔයාලා ලිව්වොත් මේ wrong format එකේදී මේක වෙන්නේ අපි මෙහෙම ලියනවා 2041 BB8 : දාලා අර බිඳු ටික ඔක්කොම අයින් කරනවා 2342 දානවා ඊට පස්සේ 00 අයින් කරලා BF දානවා 3210 දාලා ආයි මෙතන 00 ටිකට කෝලන් එකක් දානවා කෝලන් ප්‍රශ්නේ තියෙන්නේ මේක long format එකට රීඩින් කරනකොට දැන් මේක අපිට දැන් මෙතන 1යි 2යි 3යි 4යි 5යි තියෙන්නේ. එතකොට තව 8 වෙන්න මේක 16 බිට් 8ක කෑලිනේ යන්නේ. 8 වෙන තව 3ක් ඕනනේ. ඒ 3 එන්නේ කොහෙටද කියන ප්‍රශ්නයක් තියෙනවා. මෙතෙන්ට බිඳුවේ 4 ඒවා දෙකක්ද එකක් එක්ක මෙතෙන්ට එකක්ද නැත්නම් මෙතෙන්ට බිඳුවේ 4 ඒවා එකක් එක්ක මෙතෙන්ට බිඳුවේ 4 ඒවා දෙකක්ද ෆීල්ඩ්ස්. 16 ෆීල්ඩ්ස් දෙකක්ද. එතකොට මේක ලියන්න පුළුවන් ක්‍රම දෙකකට අපිට බැලුවොත්. එකක් මේ විදියට එකක් මේ විදියට. එතකොට අපි දන්නේ නැහැ හරි IP address එක මොකක්ද කියලා. ඒ හින්දා මේ රූල් එක දාද්දි මේ වගේ තැන්වලදී පරිස්සමෙන් ලියන්න ඕනි. මෙතනදී වැඩිපුරම බිඳුව ඒවා තියෙන තැන කියන්නේ ගොඩක්ම පාවිච්චි කරලා ලොකුවට ෂෝටන් කරන්න පුළුවන් පැත්ත බලලා තමයි වැඩිපුරම බිඳුව එක ළඟ තියෙන ඒවා ටික අල්ලලා බිඳුව එලිමිනේට් කරනවා. අනිත් බිඳුවේ තියෙන ටිකට ෆස්ට් රූල් එක විතරක් ඇප්ලයි කරලා අර ලීඩින් 0 සයින් කරලා අන්තිම 0 එක විතරක් තියෙනවා. ඕක තමයි කරන්නේ. එතකොට මේකෙදි ප්‍රශ්නයක් නැහැ කන්ෆියුෂන් එකක් නැහැ. මේක මෙතන මේක හදද්දි 2041 0DB8 මෙතන 0 ඒවා 4යි I colon 0 ඒවා 4යි 00BF 3210 I 0 ඒවා 4ක් තියෙනවා. මොකද මෙතන 0 එකක් තියලා තියෙනවා. ඕක තමයි වෙන්නේ. So I'll do it again. Let's this is the the rules that we will be looking at. So just again I'll do it like say for example 2041 0DB8 000 000 3204 000 000 1 2 3 4 5 6 7 and the last one is 00B. Now you are having that one. So whenever you are going to do that make the shortening, so the easiest way is to 2041:DB8. In here we can't see that the here we have the two double consecutive 2 zeros in here, and as well as in other locations we have 2 consecutive zeros. So we are actually having issue that what we are going to shorten with the first rule number 2. obviously you can decide, because either one you have to, you got it, the same shorten will be there. So either you can say like this will be like 0 0, eliminating only applying the first rules, that is eliminating the leading zeros, and then 2 2 2 3 2 0 4, and here we are eliminating all the zero consecutive zero BA. Someone can write it down this in this different way. Okay, make it look at this. So it's almost same. The shortening will be look like same. So this will be shortened, and then 3240 and 0 0 and then BF. So you can see the length of the shortening will be equal. මොකද මෙතන තියෙන්නේ එකම consecutive zeros, මෙතන fields දෙකයි, මෙතනත් දෙකයි. දෙකෙන් ඕන එකක් ඔයාලට ගන්න පුළුවන්. So you can see it's almost the same. Nothing to worry. So this is how you are going to deal with the shortening these things. So are you clear, guys? Guys?
Yes, sir.
Yes, sir.
Unfortunately, since we have covered up important session, okay, so someone asked questions like how we are going to write out the this type of address space. Like of course, just to give you idea that this is, we have to have the not the dot colon 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 colon. So you can shorten these things in this manner. So you can write it down to normally in the IPv6 you can say 0 colon colon A B C 0 colon 0 colon 0 colon A C D A colon 0 and colon 0. Or you can write it down in this manner: 0 colon 0 ADC 0 colon colon ACDA colon 0 colon 0. Or else you can write it down in this manner: 0 colon 0 ADC 0 0 colon 0 ACDA colon colon. So these are the three different ways that you can write it down, this particular IPv6 address. So you can write it down in these three ways.
ඒතර ක්‍රම තුනම හරිද?
තුනම හරි. ඇයි ඔයාලට මේකේ ඕන තැනකින් ෂෝටන් කරන්න පුළුවන්. මොකද මේකේ consecutive zeros තියෙන්නේ 16 2යි ආයි 16 2යි ආයි 16 2යි. ඒ හින්දා ඉතින් අපිට ඕන එකක් ඩිසයිඩ් කරන්න පුළුවන්. මේක හැබැයි 16 1යි 2යි 3ක් තිබිලා මෙතන දෙකක් තිබ්බොත් අනිවාර්යෙන් මේ තුන තියෙන එක තමයි ෂෝටන් වෙන්න ඕන. දැන් මේක I'll write it down in this way. So if you do have 0 0 0 0 0 0, then again you have the ADC 0 and then ACDA C colon 1 2 3 4 5, like 0 0 AC 6 7 8. In this manner, what you can do is you can write it down in the level of this colon colon ACD 0 ACDA AC 0 and 0. This is the only method that you are having to write it down. Is it clear, guys?
Yes, sir.
Yes,
So
sir.
what about the others?
Yes, sir.
Yes, you can use the double colon one time only. That is exactly correct.
IPv6 වල ක්ලාස් තියනවාද?
So guys, just keep in mind that whether you are having 2 consecutive or 3 consecutive zeros, we just put only colon colon, colon dekai dani. We can have the multiple 4 consecutive zeros even, but that representing with the 2 colon in between this one. So here we can say that these 2 colons will represent in 3 consecutive zeros of 16-bit blocks. So if you have 16-bit blocks of 4 consecutive zeros, even that also representing with the colon colon only.
So අන්තිමට හදපු උත්තරේ මේ ඊට උඩින් තියෙන මේ IP address එකකින් හැදුවේ.
Oh, මෙන්න මේකට.
හරි සර්.
ඒකට තමයි මේක හරි තියෙන්නේ. Clear the guys? Are you clear with this?
Yes, sir.
Okay. So unfortunately, we need to go through an assignment. What we are going to do? So we'll go through. So the assignment is based on the IP address shortening that we have done so far. So I will give you
Is this assignment, sir?
Yeah, this is the assignment.
So we have shortened these things.
Yeah, you need to write it down in a shortened form. 1, 2, 3, 4, 5, 6, 7, 3, 6, 7. 1, 2, 4, 5, 6, 7, 8. Right, so we have 5 IP addresses. You will get just send me the answers through the chat. You will get again 5 marks for the chat, 5 marks for the assignment. So this is to answer that. Then for the shortened form to longer form, how can we find the position of zeros? Of course, you can find the position of zeros. I'll show you once you complete this assignment. I'll show you how to do that. So guys, so I need your answers. So I'll give you 10 to 15 minutes to complete your answers. So just send through the chats. So that will be easy for me.
පේන්නේ නැතුව ගියා.
අපේ නේද?
Yes, sir.
So it's just a small assignment, like it's again 5 marks assignment that you are getting. So nothing to worry. Right. So since everyone has completed the assignment, so we'll move ahead. That I'll just answer to that question. Like still I'm receiving the answers. Are you not yet? So just everyone is completed the assignment or not? Because I'm still receiving someone is still sending the answers. So I'll give you, there is one question asked. So shorten form to longer form, how can we find the position of the zeros? I mean, you don't want to find any positions because this is like if you look at this particular one, like say for example, if I take the third one, if I shorten the third one, just get this one. This is third one. We are going to take the shorten this one. 2400 colon FE0 colon FFE0 colon colon, there are 3 consecutive zeros. We are going to eliminate 3 consecutive zeros. 300 colon 0. So now you don't want to decide, or whenever you are going to rewrite from the longer form, you don't want to decide where the zeros are in the it's laid, because it's by looking at this you can easily understand, because here 2400 even this is obviously in the middle of the IPv6 address, these zeros are there. So 0FE0 colon FFE0 colon colon 0 0 0 0 0 0 0 3 3 zeros 0 300 colon 0 0 0. So this is exactly, you don't want to worry about it, because by looking at whenever you see the double colon, that is where exactly the consecutive zeros are located. So it can be the middle, it can be the beginning, it can be the last. So we don't know where it is. Based on the IPv6 address, that is going to be said it, simply said it. So I guess you received the answer for that question. Hello. So so basically, shorten form to longer form, how can we find the position of 0? Obviously, you don't want to find the positions, as I mentioned. You know where the positions are located by looking at the IPv6 address. So this is this is how you are going to deal with this IPv6 address and initiating the IPv6 address in a longer term, that where you going to look at. So are you clear, guys? This is just the basic concepts that we are still in, because we have a lot more to go. We have a lot more to learn on the IPv6 environment. Just to this is how we build up the IPv6 address, but there are so many things that we need to learn. Are you clear, guys? This one. Do you have any issues, concerns so far? What we have done until up to now? So I'm receiving still the. Okay, so do you have any issues, concerns? I guess you are fine with this one. So we'll now the thing is like you can see the how long this IPv6 address is. So when you going forward, it is very much not practical. Like whenever it is coming to the IPv6 address configurations on the devices, it is very much not practical to do it. And there are like if you look at the IPv4 addresses, we have a different type of IP, special IP addresses like loopback IP address, multicast IP address, so broadcast IP address. We have a different type of special type of IPv4 addresses. In the IPv6 also, we have the same type of IPv6 addresses scheme as well. So we'll start with the first thing, like so basically, when you're dealing with this IPv6 address scheme. So we do have a different type of address spaces, addresses. So like we are going to do deal with it. The first thing that we will be going to learn here is there are three different type of IP address types like unicast multicast IPv6 addresses,
Any cast.
and then anycast IPv6 addresses. So we do have the different type of IPv6, the major three different type of IPv6 addresses: unicast, multicast, and the anycast. Can anyone tell me difference between these three things? Like what are these things? Unicast, multicast, and the unicast.
Unicast for specific destination.
Okay.
Multicast for every destination in the network. Anycast for nearest destination.
No. So when you're dealing with the IP address scheme, so unicast in the sense we exactly talk into one IP, one PC to another PC. Like say for example, if you have in layman term in the hypothetical scenario, when you are going to have a talk with one of your friend, that is going to be the unicast, one-to-one chat. So you are going to exactly chat to one of your friend. So it's one-to-one chat, that is called as unicast. Multicast in the sense right now I am delivering a lecture to the multimedia network and the software people on the 2017 batch or 2006 17, I guess you right, 2017 batch. That is exactly going to be there. So that is a multicasting that I'm right now running. So I'm delivering to a specific, I'm delivering a lecture to a specific group. So whenever the IP address is going to address to a specific set of groups, PCs, that is called the multicast address. So if I going to deliver a lecture to the whole environment, like the whole university, that is going to be the anycast. So which is sort of addressing to everyone. So it's called anycast. So these are the three different type of addressing schemes that we are going to use it in here: unicast, multicast, and anycast. Is it clear, guys? So what about the others?
Yes, sir.
Yeah, sure. I'll repeat it again. So these three things like unicast, multicast, and anycast, what they are exactly looking at here is uh, unicast in the sense we will be talking one PC to another PC, exactly single to single. What exactly looking at here is the like a chat with one of your friends. So one-to-one chat. So we are from one PC that is going to distinct to another PC, which is a single chat. So where no one can hear or no one can listen on that particular chat. That is called unicast. One-to-one communication. Uh, one to specific group communications, like what we call it as a multicasting. Multicasting in the sense what we are going to do here is we will be going to exactly talk to a from one that is like I am delivering a lecture to you guys. So I'm delivering a lecture to the specific group, that is 2017 batch 1 students. So that is a multicast. So specific group that I'm addressing. So whenever the computers also can address to a specific group, that is addressing the multicast environment. So then the anycast in the sense whenever if I am going to deliver the lecture to everyone, if I'm going to deliver the lecture to everyone, so that is going to be the anycast. Exactly that what we are going to learn in here. Are you clear now?
Anycast mean like broadcast?
Yeah, exactly similar to the broadcast. So I guess still I'm receiving the answers, guys. So don't send the answers now, it's over. Right. So that is about the actual unicast, multicast, and anycast. So hope you are clear with the IPv6. This is just introductions. So from this point onwards, we are going to learn several other important concepts like the addressing types and then different type of addressing schemes. Of course, we are not going to discuss about the subnetting in this particular chapter, which is going to be a sort of a advanced concepts which we are going to not discuss in this level. But the most of the other important thing will be going to discuss in this particular course content. So there will be definitely will be having another 2 to 3 sessions. Sorry, 2 sessions most probably that will covering the rest of the things in the IPv6. Okay, so with this, we are going to wind up for today, and we'll guys meet on next most probably Wednesday. I will send you the not next Wednesday because sorry guys, next week I'm not able to do the lectures because I am having another sessions for actually training sessions, which is going to be a sort of important sessions that I'm doing. So most probably next week we'll be not going to have the lectures. So after that week, definitely we are going to have like we can have 2 weeks lectures on that after that week. Okay, guys. So I'll let you know if there's a time. I'll let you know, or else we can have the lectures on next week Friday. Is it okay, guys? Guys.
Okay.
Okay.
Okay,
Okay,
sir.
sir.
Okay, then I'll send you the links for the next week Friday. So we'll meet on that day. Okay, guys. So have a nice day and have a nice week ahead as well. So we'll meet on next Friday, and I'll send you the link. Stay safe, guys. Until see you and bye bye.
Thank you,
Thank
sir.
you, sir.
Good
Good
night.
night, sir.
Goodbye.